Long before we ever walked on the moon, we looked at another world, red, silent, distant, a planet that shimmered in the night sky with an ominous glow. To ancient stargazers, it was the god of war. To modern explorers, it is the future home of humanity. This is the story of that planet, not one of aliens or fantasy, but of geology, ice, dust storms, and ancient rivers, of orbiters, rovers, and robotic explorers, of everything we know so far about the fourth world from the sun. Welcome back. I am Ryan and you are watching For All Mankind. So close your eyes and let us journey to the red planet, where silence reigns and science whispers through dust and time. Mars is our neighbor, orbiting just beyond Earth at an average distance of 225 million kilometers. It's the fourth planet from the sun, about half the size of Earth, but nearly twice the size of the moon. Mars occupies a strange middle ground, Earth-like enough to tease possibility, but alien enough to humble every mission sent its way. Its day, called a sol, is just over 24 hours long. Its gravity is about 38% of Earth's, and its thin atmosphere, composed mostly of carbon dioxide, barely registers above a vacuum. Still, it has clouds, winds, seasons, and polar ice caps made of both water and dry ice. At first glance, it's dead, but dig deeper, and the evidence of a once active world is everywhere. Mars today is cold and dry. But it wasn't always that way. Billions of years ago, the planet may have been blue. Evidence from satellites and rovers suggests a watery past, of flowing rivers, deltas, ancient lakes, and maybe even a vast northern ocean. The Mars Reconnaissance Orbiter has photographed branching river channels, sedimentary layers, and mineral deposits that only form in liquid water. Curiosity, the rover, found clay and sulfates, signs of long-standing water. Opportunity discovered hematite spheres, iron-rich marbles that form in wet environments. And Perseverance? It's now searching an ancient river delta in Jezero crater, a site once filled with water and potentially life. Mars is red because of rust. Its soil, rich in iron oxide, scatters sunlight in a way that gives the planet its iconic hue. From orbit, you can see impact craters, deep canyons, giant volcanoes, and dust storms the size of continents. The largest volcano in the solar system is here, Olympus Mons. It rises 21 kilometers high, 3 times taller than Mount Everest. And then there's Valles Marineris, a canyon system stretching 4,000 kilometers long. If placed on Earth, it would run from New York to Los Angeles. No tectonic plates exist on Mars, but it bears the scars of ancient chaos. Asteroid impacts, eruptions, and vast floods that once tore across its surface. Mars has 2 tiny moons, Phobos and Deimos. Both are irregularly shaped, like captured asteroids, and orbit the planet in rapid, unstable paths. Phobos, the larger of the two, is only 22 kilometers wide. It orbits so close to Mars that it rises and sets twice a day, and it's slowly falling, destined to crash into Mars or break apart into a ring within 50 million years. Deimos, smaller and farther away, is more peaceful, but both moons remain mysterious. Were they formed from Mars itself, or captured from the asteroid belt? Future missions plan to land on Phobos, hoping to solve its riddles and use it as a staging point for Mars exploration. Mars exploration began with failure. In the 1960s, the U.S. and Soviet Union launched dozens of missions, many of which never left Earth's orbit or lost contact en route. The first success came in 1965 with Mariner 4, a NASA spacecraft that flew by Mars and sent back 21 grainy images. It was the first time humanity saw another planet up close. Then came Mariner 9, the first orbiter, in 1971. It revealed a world scarred by dust storms and strange landforms. The Soviet Mars 3 managed a brief landing, though contact was lost after just 14 seconds. Every mission since then has built upon the last, carving a path of perseverance through failure, discovery, and wonder. In 1976, NASA made history. Viking 1 and Viking 2 became the first successful landers on Mars. They not only sent back stunning photographs, but also carried experiments designed to detect life. The results? Controversial. One experiment hinted at possible biological activity. The others found no organic molecules. To this day, scientists debate whether Viking's instruments were too crude, or if they glimpsed something extraordinary, only to dismiss it. Regardless, Viking set the bar for Mars exploration, showing that landers could survive, operate, and transmit data from the Martian surface for years. The modern era began with Spirit and Opportunity, twin rovers launched in 2003. Expected to last 90 days, they exceeded all expectations. Spirit roamed Gusev crater for 6 years. Opportunity lasted nearly 15 years, traveling over 45 kilometers, an off-world record. Then came Curiosity in 2012, NASA's nuclear-powered lab on wheels. It explored Gale Crater and climbed Mount Sharp, analyzing rock layers that preserved the planet's watery history. In 2021, Perseverance landed in Jezero Crater, accompanied by Ingenuity, a tiny helicopter that proved flight was possible on Mars. Today, these robotic pioneers act as geologists, meteorologists, and scouts, preparing the way for future astronauts. We've only just begun to scratch the surface. In the silence of space, Mars waits, but in its dust, echoes the past. Mars, known as the Red Planet, has been a constant presence in our night sky and our collective imagination. But beneath its dusty surface lies a world shaped by ancient cataclysms and silent transformations that have occurred over billions of years. Let us begin with the story of water on Mars. Once, long ago, rivers snaked across its plains, and vast lakes shimmered beneath pinkish skies. Evidence from orbiters and rovers suggests that Mars was not always the dry, desert-like world we see today. Features like valley networks, delta deposits, and even signs of shorelines etched into crater rims whisper of an ancient Martian past dominated by liquid water. In 2015, NASA confirmed that recurring slope lineae, dark streaks that appeared seasonally on Martian slopes, may have been caused by briny liquid water. Though later studies questioned this conclusion, the excitement surrounding it highlighted how desperate we are to understand water's role on the planet. After all, where there's water, there might be life. Mars' atmosphere today is thin, only about 1% the density of Earth's. It's composed mainly of carbon dioxide, with traces of argon, nitrogen, and a smattering of oxygen. Because the atmosphere is so tenuous, liquid water can't remain on the surface for long without evaporating or freezing. Yet, billions of years ago, this was not the case. Scientists believe that Mars once had a much thicker atmosphere, possibly sustained by a magnetic field like Earth's. But around 4 billion years ago, that magnetic field collapsed. Without protection from the solar wind, charged particles streaming from the sun, the Martian atmosphere was slowly stripped away into space. NASA's MAVEN mission, which arrived at Mars in 2014, has helped confirm this. It detected ions escaping the planet's upper atmosphere, further supporting the theory that the sun played a critical role in the planet's transformation. One of the more haunting features of Mars is Olympus Mons, the tallest volcano in the solar system. At 22 kilometers high, it dwarfs Mount Everest. It is so wide that if you stood at its base, you wouldn't be able to see its summit because of the curvature of Mars itself. Olympus Mons is a shield volcano, similar to those in Hawaii, and it formed over hundreds of millions of years. Mars' low surface gravity and lack of plate tectonics allowed magma to rise repeatedly through the same surface openings, creating this massive structure. Nearby lies the Valles Marineris, a canyon system over 4,000 kilometers long and up to 7 kilometers deep. It is more than 10 times longer and 4 times deeper than the Grand Canyon. Scientists believe it may have formed due to the stretching and cracking of Mars' crust as volcanic activity expanded the nearby Tharsis region. These vast landscapes, shaped by volcanic, tectonic, and erosional processes, are relics of a planet that was once geologically alive. Today, Mars is quieter, though not completely dormant. Marsquakes, detected by NASA's InSight lander, reveal that the planet still trembles from internal stresses. These quakes are often mild, but they tell us that Mars is not a dead world, only a resting one. The planet's reddish hue comes from iron oxide, rust, that coats its surface. But in some regions, different minerals hint at a more complex history. Hematite, clays, and even opaline silica have been discovered by rovers like Opportunity and Curiosity. These minerals typically form in the presence of water, suggesting that ancient Mars was chemically dynamic. The Curiosity rover, which landed in Gale Crater in 2012, has been pivotal in painting this picture. Gale Crater likely once hosted a large lake and sedimentary layers within its central mountain. In 2021, NASA's Perseverance rover joined the exploration, landing in Jezero Crater, an ancient river delta believed to be one of the best places to search for signs of past microbial life. It brought with it a suite of advanced instruments, including the Sherlock and PIXL devices for analyzing rocks at microscopic levels, and it even carried the Ingenuity helicopter, the first powered flight on another planet. Perseverance's mission is part of an ambitious plan to collect samples and cache them for a future mission to bring them back to Earth. If successful, it would be the first time humanity retrieves rocks from another planet, a moment that could redefine our understanding of life's potential beyond Earth. Another recent discovery that sparked excitement was the detection of possible subsurface lakes beneath Mars' south polar ice cap. Radar data from the European Space Agency's Mars Express orbiter hinted at pockets of liquid water. While the temperature and salt levels would make these lakes extreme environments, they mirror conditions where extremophile microbes survive on Earth. Mars' polar ice caps, made of water ice and dry ice, frozen CO2, grow and shrink with the seasons. Each layer holds a frozen record of Martian climate shifts, much like ice cores do for Earth. Studying these layers can reveal how Mars' tilt and orbit have changed over millions of years, factors that impact its climate cycles. The possibility of life on Mars remains one of science's most tantalizing questions. Although no definitive evidence has been found, the presence of methane, a gas often associated with biological activity, continues to intrigue researchers. Methane plumes have been detected at different times and places, and their origin remains a mystery. Did ancient microbes once thrive in Martian lakes and rivers? Are dormant life forms hidden beneath the surface, waiting to be awakened? Or is Mars a barren world, forever silent, with only geological ghosts whispering of a wetter, warmer past? As we prepare for the next wave of exploration, including potential human missions, these questions remain at the forefront. And in the silence of the Martian deserts, we may one day find answers that change everything we know about life in the universe. For many years, scientists assumed Mars was a geologically dead world. No tectonic plates, no churning mantle, just a silent, frozen desert. But everything changed in 2018, when NASA's InSight lander detected the first recorded Marsquake, a deep rumble beneath the surface of a supposedly quiet world. These quakes revealed something shocking. Mars is still active, not like Earth, with drifting continents and constant volcanism, but its interior isn't cold and lifeless. Instead, it's slowly cooling, releasing pent-up energy in the form of small but distinct quakes. InSight's instruments recorded over 1,300 quakes, some lasting over an hour. Most were gentle, but a few reached magnitudes strong enough to shake boulders. These quakes taught us more about the Martian crust, revealing a fractured, brittle outer shell with echoes of ancient activity still reverberating through it. Why does this matter? Because if Mars is still geologically active, it could help sustain subsurface environments, maybe even one suitable for microbial life. Imagine a dust storm so large it swallows an entire planet. On Mars, that's not a sci-fi scene. It's reality. Every few years, Martian dust storms grow from local tempests to global events, darkening the sky and halting solar-powered missions. The most infamous storm occurred in 2018, when a planet-wide tempest engulfed Mars and forced NASA's Opportunity rover into hibernation. It never woke up. The storm lasted over 100 days, coating solar panels with dust and reducing visibility to near zero. Martian dust is incredibly fine, talc-like, and electrostatically clingy. Once airborne, it stays suspended for weeks. Winds on Mars aren't particularly strong. The atmosphere is just 1% as dense as Earth's. But dust storms expand due to solar heating, triggering chain reactions across regions. Understanding these storms isn't just academic. Future human explorers will need to survive them, protect habitats from static buildup, and engineer solutions to clean dust from equipment. Water has always been the prize. Without it, human survival on Mars is virtually impossible. For decades, scientists looked for signs of it. Not just ice at the poles, but flowing, usable water. In 2008, NASA's Phoenix lander confirmed water ice just beneath the surface. A few years later, orbiters detected recurring slope lineae, dark streaks appearing seasonally on Martian hillsides. Some thought it might be salty, briny water oozing from underground, but later studies cast doubt on that, suggesting dry flows of sand instead. Then came a bombshell in 2018. Radar reflections from ESA's Mars Express orbiter hinted at a possible subsurface lake beneath the South Polar ice cap. A salty, liquid reservoir more than a kilometer beneath the ice. If true, it's the closest thing to an alien ocean we've found, and possibly a refuge for microbial life, protected from radiation and extreme cold. Could we turn Mars into a second Earth? The idea of terraforming, transforming Mars into a habitable world, has fascinated scientists and dreamers alike. But how realistic is it? Proposals range from melting the polar ice caps to releasing greenhouse gases and thickening the atmosphere. Others imagine giant mirrors in orbit or genetically engineered bacteria spreading across the Martian soil. The problem? Mars is simply too cold and its atmosphere too thin. It lacks a magnetic field, meaning solar wind constantly strips away atmospheric particles. Even with advanced tech, making Mars Earth-like would take centuries, if not millennia, and untold resources. Still, it raises a fundamental question. Should we even try? Should Mars remain pristine, or become a second home? For decades, a human mission to Mars was a distant dream. But now, NASA, SpaceX, and international partners are actively preparing. SpaceX's Starship, with its massive payload capacity and reusable design, aims to send the first humans to Mars in the coming decades. NASA's Artemis program, aimed at returning humans to the Moon, is the stepping stone to Mars. The plan is clear: master lunar operations, build gateway stations, then venture outward. Radiation remains the biggest challenge. On Mars, astronauts will face high-energy particles from space. Without proper shielding, long-term exposure is lethal. Food, oxygen, fuel, all must be brought or produced locally. And then there's the psychological challenge of isolation on a planet millions of kilometers from home. But for all the risks, the reward is unmatched: becoming a multiplanetary species. Mars exploration is entering a golden age. With rovers like Perseverance collecting samples, future missions will return them to Earth for detailed analysis, possibly confirming signs of ancient life. Private companies are testing landers, habitats, and life support systems. NASA plans for crewed missions in the 2030s. Meanwhile, China and other nations are racing to claim their place in Martian history. And through it all, Mars remains unchanged, silent, ancient, watching, waiting for the day when the first human footprint leaves its mark in red dust. Mars isn't just a destination. It's a mirror, a frozen world that echoes Earth's past and hints at its possible future. As we dream of stepping onto alien soil, we must ask, will we be explorers or just visitors? Thanks again for watching For All Mankind. Stay curious,